The vertical line test determines if a given relation is a function or not. So, if no vertical line intersects a graph in more than one point, then y is a function of x. Let's look at the graph A. If I draw a vertical line, it intersects the graph only once. It does not matter where I draw, it always intersects the graph only once. By the vertical line test, this is a function. How about the graph B? If I draw a vertical line, it intersects the graph twice, so this is not a function. How about the graph C? If I draw a vertical line at x is equal to 2, the line intersects the graph only once at y is equal to 1. At the point x is equal to 2 and y is equal to negative 2, it is open, so the line does not pass through that point. Similarly, when the vertical line x is equal to negative 2, that line intersects the graph only once, so this is a function. What if this point is closed instead of open? Is this still a function? In this case, the vertical line intersects the graph twice, so this is not a function. Let's look at the graph of y is equal to x minus 2. First, let's check if this is a function. If I draw a vertical line, it intersects the graph only once, so this is a function. Using function notation, we can write f of x is equal to x minus 2. Let's find the domain and range of this function. The domain is the set of x values, and the range is the set of y values. If we think about the domain as the set of input values and the range as the set of output values, function f takes an input value, then gives an output. A set of x values goes from negative 4 to 6. When x is equal to negative 4, the function is open, so negative 4 is not included. When x is equal to 6, the function is closed, so 6 is included in the domain. Now let's find the range. The set of y values goes from negative 6 to 4. When y is equal to negative 4, the function is open, so negative 6 is not included. When y is equal to 4, the function is closed, so 4 is included. We have the following domain and range for this function. Let's evaluate f of x is equal to x minus 2 for the given values of x. How about f of negative 2? x is equal to negative 2. So we need to substitute negative 2 into x. We have negative 2 minus 2 is equal to negative 4. How about f of 0? Let's find the y value from the graph. When x is equal to 0, y is equal to negative 2. So the answer is negative 2. Using the function, we get 0 minus 2, which is negative 2. Let's evaluate f of 4. From the graph, we know that y is going to be 2. Let's check. So we get 4 minus 2 is equal to 2. Now let's find one value of x for which f of x is equal to 0. So 0 is the y value. From the graph, when y is equal to 0, x is equal to 2. So the answer is 2. Let's check using the function. We have x minus 2 is equal to 0. So x is equal to 2. We have y is equal to negative x minus 2 squared plus 4. This is a function by the vertical line test. Let's find the domain and range of this function. The function takes all values of x, so the domain is from negative infinity to infinity. The set of y values goes from negative infinity to 4. So the range is from negative infinity to 4 included. Let's evaluate f of x for the given values of x. How about f of a? X is equal to a, so we have negative a minus 2 squared plus 4. Let's evaluate f of 2x. We need to substitute 2x into x. So we get negative 2x minus 2 squared plus 4 is equal to negative 4x squared minus 8x plus 4 plus 4 and negative 4x squared plus 8x minus 4 plus 4 and we get negative 4x squared plus 8x. And we can factor x out and we get negative 4x times x minus 2. How about f of t plus h? So x is t plus h. We have negative t plus h minus 2 squared plus 4. And you can simplify.